Okay, day 3. All right. It says, given the line segment MN shown below, with the point M as -6, 1 and N 3, -5, what is the equation of the line that passes through the point 6, 1 and is parallel to that line? Okay, so we got to come up with an equation that is parallel to M of N and goes through the point P. Okay, so in order to do that, all right, first we need to figure out what is the equation of this line right here. And really, we're not more or less focused on what the equation is, more or less on what the slope is. Okay, so I'm going to look at this point right here. See how it falls on that nice cross here? Can we zoom in here? Falls on that nice cross here. Okay, so if we go down 2 over 3, don't forget that's rise over run. So we're going down 2 over 3. So our slope for this line here is -2, 3. And we actually can find the y-intercept if we wanted to, right? We could find that. So our equation is -2/3 x minus 3. Okay, that's the equation of that line. All right, so we want the equation of a line that passes through this point here and has the same slope, which is -2, 3. That's what it means to be parallel. All right, so in order to find that, we're going to use our point slope formula, which is y minus y1 is equal to m times x minus x1, where x1 and y1 is just some point. So in this case, our point is 6, 1. Our slope is -2, 3, so we just fill in the blanks. Y minus 1 is equal to -2/3 x minus 6. All right, you're going to distribute that -2/3, so -6 times -2/3 is equal to 4, so y minus 1 is equal to -2/3 x plus 4, right, because 2 negatives equal a positive. Add 1 to both sides, you get y is equal to -2/3 x plus 5, and do we see that equation over here? We better. We sure do. So our answer to that problem is number 1. Okay, so let me reiterate the process. First, we need to find the slope of that line, which we could have found. We found the equation as well. Okay, but we've got the slope, and so in order to create a line that's parallel to the line, we needed the same slope, and we plugged it into our point slope formula. Okay, so that's number 11. Number 12, determine and state the equation of a line perpendicular to this line right here and passes through the point 5, 12. Okay, so we're talking about a line that's perpendicular, which means, all right, when we find the slope of this line right here, all right, we're going to need the negative reciprocal. Okay, so let's find out what our slope is first, right? Because this form doesn't really tell us anything. This is the standard form. Okay, so in order to get it into the slope-intercept form, we have to solve for y. So subtract 5x, I get -4y is equal to -5x plus 10. Divide by -4, y equals 5 over 4x minus, and 10 divided by 4 is 2.5. Okay, so we're not really too concerned about all that. All we really are concerned about is this number right here, at 5 over 4. All right, so our slope is 5 over 4. So what we need is a slope of -4/5, and then passes through this line right here. So y minus y1 is equal to m x minus x1. So we fill in the blanks. Y minus 12 is equal to negative 4/5 x minus 5 plus 4. Add 12 to both sides. Okay, and you should end up with an equation. Let me write it up here. Y is equal to negative 4/5 x plus 16. Okay? And that's the equation of the line passing through that point, and it's perpendicular to that line right there. Okay, so number 13. In the triangle MAH, M and T is the perpendicular bisector of AH. So which statement is not always true? So when we're talking about the perpendicular bisector, it means this is 90, and also means those two sides are the same. Okay? Now, it says which statement is not always true. So it says MAH is isosceles. Okay. Let's read them all. MAH is isosceles. MAT is isosceles. MT bisects the angle AMH, and angle A and angle TMH are complementary. So which statement is not always true? Okay. Well, let's think about this here, all right? MAT is isosceles. See, I'm looking at these. Okay. All right, I get it. All right. So how do I want to explain this one? This one's kind of tricky in the sense that, all right, so we haven't really talked about isosceles triangles, but basically in an isosceles triangle, okay, when you set up the altitude, okay, which is this height right here, this is our height, our altitude, okay, when our height, our altitude is the perpendicular bisector, which means that when we draw this line, when we draw that, when we draw our altitude, okay, we get 90 degrees. It splits these two sides. And that means it also splits these two sides. Okay. Now, so this one is true. All right. In an isosceles triangle too, when you have this perpendicular bisector, it also bisects this angle up here. Okay, so this one's true. This is angle A and angle TMH are complementary. That's true, right? That makes sense because this angle right here and this angle right here added up must add up to 90 degrees, right? Because this angle right here is 90 degrees, so this one is true. So the only one that's not true is number 2, okay? So this goes back to when we're talking about isosceles triangles. And when you have an isosceles triangle, don't forget, these two sides are the same, which means these two angles are the same, okay? So when you draw this perpendicular bisector, which is also referred to as our altitude, okay, not only does it split this side in half here, right, but it also bisects these two angles as well. Okay, so this only works for isosceles triangles, but it says MAT is isosceles, okay? That wouldn't be true because that would mean that this side right here would have to be equal to these other two sides here. Okay, and it doesn't mention anything about that in this problem right here. All it mentions is that M and T is the perpendicular bisector of AH. So what that does is that helps us conclude that this has to be an isosceles triangle. Okay, because if it's the perpendicular bisector, okay, that means that side and that side is equal, okay, which means that this had to have been an isosceles triangle. Okay, so the only one that's not true is MAT is an isosceles, because this height isn't always necessarily the same as these two sides right here. Okay? All right, so look at number 14. Which equation represents a line parallel to the y-axis? Well, this one shouldn't take too long, right? Our y-axis. It's that line right there. Okay, so which equation is parallel to this line? Okay, so remember our Hoy-Bucks. Okay, we want a line that's going up and down, so we want a vertical line. So we want a Bucks problem. All right, which means we need an x. So I can cross those out, and x equals y is not what we're looking for. So x is equal to 4, and if I draw that in there, 1, 2, 3, 4. That is our line x equals 4, and then that is parallel to our y-axis. All right, so going to the next problem, I put these problems together. So let me draw our axes in here again. Okay, y, x, all right. So which equation is parallel to the x-axis? Okay, so which means we need a Hoy problem, right? Because we need a line that's going horizontal. Okay, so we need a y equals. So I'm going to cross out these ones. And then this one is definitely not going to be parallel, right? That's got a slope and everything. So y equals 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Y equals 10 is that nice horizontal line right there. So for every value of y, or for any value of x, y is equal to 10. Okay? So this one is 15. All right, 3 problems and we're done here, guys. All right, so write an equation of a line perpendicular to the line segment whose endpoints are -1, 1, and 7, 5. Okay, so let me draw this axes in here, okay? So there's that one. And there's that axis. So y, x. All right, so -1, 1, and 7, 7, -5. 1, 2, 3, 4, 5. All right, and draw those endpoints in there. Okay, so there is our line. So we want to write an equation of a line or equation of the perpendicular bisector of that line. Okay, so what that means is we want to cut this line in half. Now, judging by where that looks, it looks like it would probably be somewhere right about on that orange dot, right? Okay, if I'm just kind of just guesstimating, and that point is 2, 3. All right, I don't know that for sure, but how I can find that out is the midpoint formula. Okay, you guys remember the midpoint formula, right? Maybe, maybe not. It's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Okay, that's your midpoint formula. So, we got our points here, so it's going to be -1 plus 7 divided by 2 over 1 minus 5 divided by 2. And so what do we get here? 6 divided by 2, which is 3. And, oh, I'm sorry, that's going to be -3, right? 2, -3. And then 1 minus 5 is -4. -4 divided by 2 is -2. Okay, so I apologize, guys. I actually had that written backwards. All right, so our midpoint is -3, comma -2. All right, which we can kind of anticipate, right? You can kind of see that. All right, but that is how you can find it for sure. So that's our midpoint. Now to come up with a line that's going to be the perpendicular bisector, okay, I need to go through this point, and then I also need to be perpendicular, okay? Which means I need to find the slope of this line and do the opposite. So 1, 2, 3, 1, 2, 3, 4. So it looks like our slope is down 3 over 4, right? Down 3 over 4, down 3 over 4. So that is our slope. Okay, so what we need is the slope of a positive 4, 3. Right? And then now we have our slope. We can plug it into our point slope formula. So y minus, and I'm going to take this point right here, right? Y minus -2 is equal to 4, 3. X minus 3, so we get y plus 2 is equal to 4/3 x minus 4. Subtract 2 to both sides, and your equation, just running out of room here again, your equation is going to be y is equal to 4/3 x minus 6. All right, so let's just draw that in there, just for fun, because we got time here. All right, so 1, 2, 3, 4, 5, 6. And we're going up 3 over 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Okay. Let me draw my line in there. It's not going to be perfect. Oh, not too bad. And I would say that looks like 90 degrees to me. Okay? So that is our equation. You write it up here. So y is equal to 4/3 x minus 6. Okay, 2 more problems. Write an equation that represents a line that's parallel to the y-axis and passes through that point. Okay? So let me draw that point on here. So 1, 2, 3, 4. 1, 2, 3. There's our point 4, 3. And we want to be parallel to the y-axis. Okay? Which means to go through that point, we don't not only want to be parallel, but we want a nice vertical line, which means we want a Vux problem. So if I want it to go through this line right here, or this point right here, okay, it's going to have to be x is equal to, and what's my x value on that line? Would be 4. So our answer is x equals 4. Okay, so we're parallel to the y-axis, and we are passing through that point 4, 3. Okay, next problem, last but not least, write an equation of the perpendicular bisector of the line segment shown in the diagram below. All right, so again, I'm just going to guesstimate that it's going to be somewhere right there, right? It looks about the middle. It falls on that nice grid point, but we don't know for sure. All right, so let's find out what this point is. So this is -2, 4. And this is 2, -4. Oh, so it kind of went backwards. All right. So, it's almost like we did a 180-degree rotation, if you will. Okay. That being said, all right, write an equation of the perpendicular bisector. So, we got to figure out what that midpoint is. All right. So I'm going to go 2. Plus a -2 divided by 2. And this is 4 plus a -4 divided by 2. Right? And so it's pretty easy to see in both cases we should get 0, 0 for our midpoint. Okay? Which we anticipated. All right. Now, let's figure out the slope of this line here. So it's going down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Okay, so our slope, which is rise over run, is down 2 over 1. So our slope is -2. All right. So unfortunately, all these problems, what a pain in the butt, okay? None of them have it as y equals, okay? Which means, all right, we're going to have to find out, we're going to have to set all these equal to y, okay? So in this one here, when you subtract 2x, you get y is equal to -2x. Add 2x here, you get y is equal to positive 2x. This one, you subtract x divided by 2, so you should get y is equal to -1/2 x. And this one, you're going to add x divided by 2, so you get y is equal to 1/2 x. All right, so which one of these has a slope of 2? It's this one. And if you want to investigate further, it's y equals 2x plus 0, right? What's our y-intercept? 0, 0. So when x is equal to 0, y is equal to 0, which means this equation right here is our correct choice. And that is all your problems for week 2. Okay, so check out your answers here, guys. I hopefully